In the last module, we looked at the locking level, and in this module, we're going to move on to the aspect level. And we're going to begin by asking the same question, what is the aspect level, before moving into some details of functionality concerned with allowing a signal to display a perceived aspect. And that includes detection of points and other movable infrastructure within routes, proving block sections are clear, permissive routes, and finally, exit signal lamp proving. So what is the aspect level? Whereas the locking level is concerned with internal states within the interlocking, the aspect level is concerned with states of physical equipment external to the interlocking. It confirms that points and other movable infrastructure are not only commanded into the required position, but physically detected in those positions required for a route when trains are authorised to enter that route over the points and other movable infrastructure. It also proves that there are no other trains in main and Warner and non-permissive shunt routes or non-permissive sections of calling on and permissive shunt routes. Signallers only allowed to display a perceived aspect to authorise a train to enter a route if aspect level conditions are satisfied for that route. And the type of aspect depends on the class of routes, which could be main, Warner, calling on, shunt or poser, the path of the route, hence any route indications required, and aspects to be displayed by subsequent signals in the case of main and Warner routes. Train can only be authorised to enter a route by means of a perceived aspect if all points in the path of that route are detected to be in the required positions, and in the case of facing points, the points must also be detected to be locked by a facing point lock, though in practice these days this comes as standard with points actuators, hence all points are in practice detected to not only be in position but locked in position by a facing point lock. We also need to detect that certain types of level crossing are closed to road traffic and clear of any obstruction before trains are authorised to over them, and any swing bridges are locked in position. Most railways, as we saw earlier, are divided into block section, and train is only permitted to enter block section on a non-permissive route like a main or Warner route if that section is proved to be clear, and there are various ways of doing this. The simplest way is known as one train working, where we only allow one train to operate, therefore there can be no other trains in the block section. But that is rather limiting if you want to run multiple trains, so there are other methods such as train staff, where only a train in possession of the train staff can enter the block section, which works quite well for little branch lines where you only allow one train onto the section at once, and only the train in possession of that train staff may enter the block section. If you want to allow multiple trains through the section in the same direction, you need something a little bit more sophisticated, like a token block system, whereby a physical or electronic token is issued to a train in lieu of a staff to authorise the train to enter that section, and electrical or electronic interlockings at either end of the section issue the tokens and are interlocked to ensure that there can never be more than one token out of the system at once, and hence never more than one train in the section. But to avoid the depletion of stocks of tokens at one end of the section and accumulation of the other, we need something a little bit different if traffic flows are predominantly in one direction, as is the case on multi-track railways. And one of the early systems of doing this was absolute block, which, like many modern signalling systems, relies wholly on signals to authorise trains to enter a block section. A signaller at one end of the block section would only clear the starter signal to allow a train to enter the block section if the signaller at the other end had confirmed that the previous train to have entered the section had cleared the home signal at the other end of the section, hence the section was clear. As we saw earlier on, that gradually gave way to automated proving of block sections clear using train detection, and that was originally using a device known as a track circuit, hence came to be known as a track circuit block. A track circuit applies a voltage between the two rails at one end or in the centre of a section to be proved clear, and a relay at the other end or ends of the section detects current flowing through the rails from that voltage source. If the section is unoccupied, the current can flow freely to the relay, causing it to energise. If a train enters the section, that shunts the current path, causing the relay to de-energise and register the section as occupied. Track circuits these days are often replaced by axle counters, which is another means of train detection, which relies on counting the number of axles entering or leaving a section of track. If the number that has left equals the number that entered, then the section can be deemed to be clear. But not all routes require block sections to be clear. There are some that allow trains to enter occupied sections or potentially occupied block sections, such as calling on routes that allow trains to couple or share platforms with other trains, or shunt routes that can allow trains to occupy sections or depots and yards without any train detection to prove them clear, or poser routes proceed on site, authority routes that allow trains to enter block sections with failed detection that may be potentially occupied. Finally, main and warner routes, except those up to buffer stops, require their exit signals to be proved alight for trains to be authorised to enter them, and this is to mitigate the risk of a driver failing to see and respond to an unlit signal. So in summary, whereas the locking level is concerned with internal states with the interlocking, the aspect level is concerned with the states of physical equipment external to the interlocking, and specifically the conditions for allowing a signal to display a proceed aspect to authorise a train to enter a route. And these include proving all points in the path of the route are in the required positions, and for non-permissive routes also include proving block sections are clear and exit signal lamp proving. In this section, we've looked at the conditions for displaying a proceed aspect. In the next couple of modules, we're going to look at what signal aspects and associated route indicators look like and how they communicate information to the driver. So please stay with me for that.